Welcome to Lovejoy, where today we would like to demonstrate the proper basic procedures for installing the Lovejoy SX spacer style disc coupling. Lovejoy disc style couplings are ideal for connecting electric motors to fans, blowers, compressors, pumps, and other devices. The SX style coupling utilizes a dual disc pack and spacer design that can accommodate axial, angular, and parallel misalignment. The SX coupling is specifically designed for applications where there is a need to transmit torque between two bearing-supported shafts with a known space between the shaft ends. The spacer configuration is ideal where a lighter weight alternative to a floating shaft is desired. For this installation, please make sure you have access to the latest copy of the Lovejoy installation guide for your particular coupling. The installation guide can be found online at Lovejoy's website utilizing the Resource tab. Then follow the link to Installation Instructions. Once you locate the installation guide, click on the PDF icon to download the guide. This installation guide contains important details such as allowable coupling misalignment and torque settings to use when tightening the set screws and bolts. Some installation guides may contain additional performance and dimensional information important when confirming the accuracy of the coupling selection. Let's look at the necessary tools we will need to perform this installation: a lockout tagout kit, safety glasses, alignment equipment, an oven, calibrated torque wrench, a socket to fit the disc pack lock nuts, an open-end wrench, vernier calipers, a micrometer to confirm the shaft sizes, heat-resistant gloves, a fine-tooth file, a strip of emery paper, non-flammable cleaning solvent, a clean cloth, and rubberized gloves. Prior to starting this installation, it is always important to ensure the equipment is in a safe and disabled state to prevent any accidental startup. Because of possible danger to the person working on the equipment, you should always consult all applicable federal, state, and local regulations covering the safe operation and maintenance of equipment. This includes, without limitation, the lockout-tagout procedure defined by OSHA. The following components are provided with the purchase of your Lovejoy SX style disc coupling. You should have two standard SX hubs, an SX spacer, two unitized disc packs, and the special disc pack bolts with lock nuts. Prior to installing this coupling, you should inspect each component to ensure that there are no visible defects, cracks, or damage from shipping, and check the bore size for accuracy. You may notice the hubs are bored slightly smaller than the equipment shaft diameters. Unless otherwise specified, Lovejoy manufactures disc coupling hubs with an interference or shrink fit, and the hubs will need to be heated prior to placing them on the shafts. We will demonstrate the installation of interference fit hubs in this video. Detailed procedures for heating the hubs can be found in the installation guide for the SX style coupling and should be used as a reference when preparing interference fit hubs for installation. Except in applications where a Lovejoy SLD or shaft locking device is used, both shafts and hubs should have keyways. To accommodate dynamic balance and allow for maximum torque transmission, the length of the key should always match the length through bore of the hub. The SX spacer style disc coupling is often used in applications where it may not be desirable to move equipment. With the equipment in place, check the shaft alignment, preferably with some sort of optical aligning equipment such as laser alignment. For this video, we will take advantage of the equipment being in place and the shafts already aligned. For this installation, we will be using the oven heat method to thoroughly and evenly heat the hubs to between 500 and 550 degrees Fahrenheit. We do not want to heat the hubs to any more than 600 degrees Fahrenheit to prevent the steel in the hubs from going through an annealing process. Heating the hubs to an excessive temperature could soften and damage the hubs. While we wait for the oven to preheat or come up to temperature, we can use our cloth and cleaning solvent to clean the surface of the hubs and remove any protective coatings used to protect the coupling during shipping. When the oven has reached the desired temperature, we will place the hubs on a rack, raise off the bottom of the oven to ensure more uniform heating of the hubs. we will need to allow enough time to ensure that the hubs are thoroughly heated to the desired temperature. The required time will be dependent on the type of oven and the size of hubs being heated. While the hubs are being heated to the recommended temperature, we will finish preparations for installing the coupling. Even though the power to this equipment was disconnected, it is always a good idea to double check that the power is off prior to physically performing this installation. It is important that you inspect the shaft and clean off any nicks or burrs from the keyway or shaft. A fine-tooth file can be used to clean burrs from the edge of the keyway or large dents in the shaft. The emery paper can be used to clear the shaft of any rust or fretting corrosion. This would be a good time to measure the shaft and ensure the shaft diameter matches the coupling bore size. Finally, with our cloth and cleaning solvent, we need to ensure the surface of the shaft and the keyway are clean and free of dirt. The disc packs and spacer should also be cleaned to remove any coatings used to protect the coupling during shipping. Place the keys in the shaft keyways, lining up the end of each key with the end of the shaft. The key should be completely seated and fit snugly in the keyway with no side-to-side movement. When the hub is installed, there should be a slight clearance over the top of the key to prevent binding and to prevent buildup of stress that can cause the hub to fail as it cools. When the hubs reach the recommended temperature, the bores will be expanded enough to provide a few thousandths of clearance when sliding the hubs onto the shafts. Make sure each hub is oriented with the flanged end of the hubs facing the end of the shafts. The key should already be in place in the keyways, and the hub should slide onto the shaft with little or no difficulty. Each hub will start cooling down right away, and you will need to work quickly and accurately to position the hubs on the shafts. Once the hubs cool down, they could be quite difficult to reposition. When the hubs are in position, the flanged end of the hub should be in line with the end of the shaft and the end of the key. At this time, let the hubs cool to the ambient or room temperature before continuing. When installing a disc coupling where one or both hubs are to be secured on the shaft using an SLD or shaft locking device, locate the SLD on the recess machined into the exterior surface of the hub. Then slide the hub on the shaft to the desired location and tighten the SLD bolts using the procedures and tightening torque specified in the SLD installation guide. The SLD is a keyless alternative to a clamping style hub and allows for axial and rotational adjustments to be made after the coupling has been installed. When the SLD bolts are loosened, the coupling hub can be removed easily without deformation or damage to the hubs, shaft, or shaft locking device. Whether the hubs are being installed using the heat method for an interference fit or installed with a keyless shaft locking device, it won't affect how we perform the rest of the installation. For the purpose of this installation, we will continue the installation with the interference fit hubs that have been installed and have cooled to ambient or room temperature. Position the spacer between the two hubs. We are installing a relatively small coupling and can support the spacer by hand. Larger couplings may require slings or other methods supporting the weight of the spacer. While we support the spacer, slide a disc pack between the hub flange and the spacer flange. Insert the bolts through the small holes in the hub flange, then through the bushings in the disc pack. The bolts should fit snugly through both the hub and the disc pack. The snug fit serves as a pilot function and is essential to maintaining the overall concentricity of the coupling. These bolts should extend into the large holes in the spacer flange. The larger holes provide clearance to get the torque wrench socket onto the lock nuts. Place a lock nut on each of these bolts and hand tighten. Next, insert the bolts through the small holes in the spacer flange and through the bushings in the disc pack. Place a lock nut on each of these bolts through the large holes on the hub and hand tighten. Repeat these last steps on the other end of the coupling by inserting the bolts into the small holes in the flanges and through the bushings in the disc pack. Place a lock nut on each of these bolts and hand tighten. When we tighten the bolts and the lock nuts, we will tighten all the lock nuts on one side of each disc pack, then the second side. Do this on one end of the coupling, then repeat on the other end. While holding the bolt heads with an open-end wrench, use the torque wrench to tighten the lock nuts first to 50%, then 75%, then the full torque specified in the installation guide. the use of a calibrated torque wrench is important. If the lock nuts are not tightened to the specified torque, the bolts could work loose, or, if too tight, they could damage the disc pack. Either condition can cause premature failure of the coupling. There should not be any visible distortion in the disc pack once the bolts have been tightened. If there is any waviness in the disc packs, the equipment alignment will need to be corrected prior to continuing. If there is any bowing or separation of the disc layers, loosen the bolts on each side of the bowed area. Reapply a thin film of grease or lubricant under the surface of the lock nuts and retighten. The angular and axial alignment can be checked using vernier calipers to measure the gap between the hub and the spacer flanges. If space permits, this measurement should be taken as close as possible to the edge of the hubs at 4 different locations around the coupling: 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock without rotating the coupling. All the measurements should fall within the PW high-low range specified in the installation guide. If any of the measurements fall outside the allowable range, you will need to realign the equipment to correct this condition. The amount of parallel misalignment allowed is a function of the length of the spacer as defined in the installation guide. This should be checked using some sort of optical alignment equipment. When the installation is complete and the equipment is aligned to meet specifications, remove any unnecessary tooling and material away from the shafting and coupling. Double-check the tightness of the disc pack bolts with a calibrated torque wrench, then prepare for testing. Install the appropriate coupling guard per OSHA requirements and remove the lockout-tagout kit from the power supply. The equipment can then be started up and tested. Check the coupling for any possible abnormalities. A strobe light with some sort of shield can be used to inspect the disc pack for any distortion. The coupling and equipment should run smoothly. If any vibration is detected, it could indicate there are alignment issues or other problems, possibly related to the motor, coupling, or driven equipment. These issues should be resolved prior to placing this coupling into operation. This concludes this particular installation video. We would like to thank you for your interest in Lovejoy Power Transmission products. Please feel free to visit the Lovejoy website for links to other videos and installation guides. You can also contact Lovejoy Customer Service at 630-852-0500. Lovejoy, building trust since 1900.